Hi, thank you very much, Lance. And as Lance said, I will get us started here with a little bit of some of the data center trends around data center growth, the use of AI, and what this means for data center interconnection. And then Philippe will take over and dive deeper into some of the solutions for this. So I love this chart, sort of giving a snapshot of data center density all around the world. Many of us, including myself, grew up in a world where the hub of communications, or if you like, the connectivity in our world, was in and around telephone company central offices. Certainly that's where all our phone calls went to, and as we sort of got older, that's where our modems went to. But in those days, besides telecommunications, we had computers, of course, and in corporations, these computers lived in closets. Obviously, everything has turned upside down and totally changed in the last 25 plus years or so. Today, we rely on computers, the compute resources they provide, the storage resources they provide to run our digital economy. And rather than living in premises of our enterprises, more and more they're living in data centers. So really it is today, data centers themselves are the hubs of our global economy, and communications is just there to support the flow of information to and from these hubs. It's an amazing pattern of growth that has taken place. Today we have over 10,000 data centers worldwide, and because these things consume a lot of electricity and a growing amount of electricity, they actually consume today more than 2% of our global electrical power. And based on continued growth of data centers and AI, which we'll just talk about in a second, what we'll see is continued pattern of this growth. And this has implications on how data centers get deployed and how they need to communicate with each other. So just looking around the industry in terms of what various analysts are saying about this, I like this link. You can click on it if you'll download the slides later on. You can see the actual quotes here. IDC, of course, is a very well-known market analyst. They expect global data center consumption to more than double between last year and 2028, a few years from now, with a 5-year CAGR of about 20%. They see this reaching 857 terawatt hours. So to put this in perspective, in 2028, the predictions say for global consumption is about 30,000 terawatt hours. So since we're approaching about 900 terawatt hours on the data center side, it's going to be almost about 3%, going up from 2% to 3% of global power consumption just in a few years from now, which if you think about it is a phenomenal amount of energy. Now, a lot of that is going to be coming from AI. AI, as we know, uses very power-hungry GPUs. And as we go more and more towards use of AI in our applications within the data centers themselves, this will consume a growing amount of this power. So you see this both in terms of another quote and also on a supporting chart. These are actually from two different sources, and amazingly, they aligned with each other phenomenally well. We see AI consuming about 15 to 20% of the total data center energy that's required. So AI, of course, will have a huge impact. Sort of diving down a little bit, just to get some examples, sort of, but we'll focus on the USA market. So this is from the same source in terms of the data center maps. This is showing a distribution of data centers across the United States. And again, depending on where you're living in the world, you can provide and obtain these kinds of maps for your own country. You can see large amounts on the East Coast, on the West Coast, with sparser amounts in some of the more remote areas, sort of following the major population and sort of industrial areas within the country. But there's a few factors that I think are worth noting, which will affect the future of our data center placements. And we'll look at this a little bit further in the next slide, but I just want to sort of give you some hints and some things to think about. So what is power availability? Because these data centers consume so much power, is only a limited ability to bring power to certain very, very dense regions. And after that, it becomes amazingly expensive. So data centers naturally have to shift to other places, perhaps nearby, but they can't just continue to be one on top of the other anymore. And in some cases, by the way, this is actually driving changes within the power industry. We're starting to hear about revitalization, for instance, in terms of small nuclear reactors. We've actually seen from some European data centers where they're actually getting into the energy business themselves because they're not able to get the power from commercially available sources, so they're having to build their own gas turbines. Another factor impacting data center placement is AI training versus AI inference. And since one of the main themes for this talk today is AI, I think it's worth talking about that a bit. So AI training is all the processing that takes place around the data sets as AI builds up its models. Now, this can take place in the background. It does not have to take place anywhere near where the actual AI itself is being implemented. And, depending on the statistics that you can see, a large amount of the power for AI actually is in the training itself. There's nothing stopping training taking place in some very remote location. And then once you have the trained data sets that are ready for use, you can ship that information back into the hubs closer to the people that are using it. On the other hand, we have AI inference, which is whereby this is the actual real-time use of AI in terms of problem solving, in terms of responding to requests. And in this particular case, it's pushing in the other direction, where we want to see the data centers that are running the AI actually closer to the end user. So there's really two things that from an AI point of view, that are doing a sort of a pull and a push in terms of where to locate the data centers or where you can locate the data centers. The other factor, and we're seeing some of this around as well throughout the literature and we're speaking with various customers, is what we call NIMBY. If you're not familiar with the acronym, it stands for Not in My Backyard. So data centers are not a terrible thing. They're not like big chemical plants that they produce a lot of pollution, although they are producing, of course, some heat pollution in terms of the power consumption. But too much of a good thing is always a problem, because it can be very, very disruptive in terms of communities when you start seeing these proliferation of buildings which are data centers, and it just becomes an upsetting type of thing. And we're already starting to see pushback, particularly in more dense areas, for people saying, we don't want another data center over here. So let's take a look at what this looks like, say, in a more microscopic view. So we've gone down from the global view down to the US view. Now we're looking at a very dense part of the USA. This is actually where there's a huge amount of data centers today in Virginia. And we see a cluster today up in the upper part of the screen. The light pink is the known existing data centers, and the darker red are the proposed data centers. And you can see up there in a very, very dense area, we see a huge clusters of data centers. What's happening is they need to continue to build out data centers within the Virginia area. A lot of this is to support the government, to support the military, to support various other types of corporations that have infrastructure over there that are serving the entire East Coast. But they cannot continue to build within the same cluster as they have before. So what we're starting to see is this cluster actually moving about 25 miles to the south into the Bull Run area. And again, a lot of this is for the reasons that I mentioned before, with power availability actually being probably the prime driver in this particular case. And what you're seeing over here is a model for data centers and connectivity, which Philippe will get into shortly, whereby you have clusters of data centers often needing to talk to each other in close proximity to each other, say within several miles. But then on the other hand, needing to also talk to each other when they're going a little bit further, and potentially even further than that. It could be in some cases actually several hundred miles away. So depending on the needs and depending on the type of data center you are, there are different types of data center interconnectivity requirements. And sort of given this kind of background in terms of the demographics of data centers, this is a good time for me to hand this over to Philippe.
Thank you, Jonathan. What I'm going to try to do here is go over a bit of why, what, who, how for data center interconnectivity. So if we go on to the next slide. So really quick, I think it's obviously very obvious to everybody, I would assume, but storage, compute of business critical applications are what's driving data centers, right? And obviously continuing that, ensuring that business continuity as well as disaster recovery capabilities. You're seeing these data centers historically, obviously, either in private campuses for enterprise customers or leveraging these cloud providers or co-location service providers that are providing this disaster recovery based on CapEx, OpEx, experience, right, resource expertise in maintaining these data centers, okay? And if we go on to the next. Now, what's driving, right? What's driving these data center build-outs even further, right? I think over the last 30, 40 years, we've seen an evolution in networking, right? If we take a look, a few decades back, it was connection-oriented, connecting two endpoints, of course, two service endpoints. A couple decades ago, or a decade and a half ago, we got into a data-led networking, right? Where you saw this Netflix effect at that time, right? Consumption of data. Right now, we're right in the middle of application-led, right? Where users, business users, devices are looking to access their applications on any device in any location around the world, right? So we're deep into the heart of applications which continue to evolve. And if we move on, right, if we look at the next, if we look at the driver, right, of these applications, the main driver of these requirements, the main driver is proximity. Proximity of these applications to the end user and device, right? And looking at obviously the evolution of 4G to 5G, looking at IoT, Industry 4.0, augmented reality, virtual reality, as well, gaming, etc. Looking at building these edge compute resources closer to the end user, right? Closer to be able to obviously deal with the performance and the need of these applications wherever they are. Okay, as even Jonathan was going through and looking at even AI. Go to the next point. Lately, AI has been that next accelerant in driving this need over the last few years. So if we look at, as Jonathan was talking about, right, with regards to AI training and AI inference, and looking at the need to build these training models and pattern identification in these centralized data centers that are being built out. You're seeing this data center race or data center arms race in the process. The moment focused on those massive core data centers doing that AI training, but as we're moving forward, you're needing the application need of these AI solutions, right? Closer to the end user, leveraging these AI data, edge data center locations based on proximity, performance, right? A good example of that is autonomous driving, right? If you look at what's being done today, you're seeing centralized applications doing the AI training, but as these patterns get defined, you're putting that into action closer to the automobile. So closer from an edge data center pointed to the end device, in this case being the automobile, being able to process the information and identifying it and putting that work into action. You're seeing that for augmented reality, leveraging AI. You're seeing that with any of these healthcare applications, of course, business applications that are coming out, leveraging AI, which the important thing to keep in mind here is that AI is still in its infancy, right? And as we're seeing this demand, we're only in the beginning of obviously this AI demand pushing further edge capabilities and data center needs closer to the end users. Okay, next slide. Now, it's important outside of understanding the application, right, and driving the need for these data centers or these edge data centers, it's understanding who, right? Who are the main data center players in the field here, right? And you can break it down into three main types. You've got your cloud services. Those are the Apples, the Googles, the Meta, AWS, right? Providing these applications that are leveraged, Office 365, for instance, these type of applications that are required and are accessed globally, right? And you're talking about petabytes of traffic within these data centers to terabytes of traffic interconnecting these data centers. So mass volume of data coming in and going out and within a data center. The other part is a co-location, right? As I mentioned before, right, as we've been evolving over the last decade and a half of these edge data centers, it's the services, right? Maintaining it. Either I maintain it as an operator or an enterprise company, pardon me, as an enterprise company maintaining my own data center, or I leverage resources or companies that are providing infrastructure, space, cooling, bandwidth, interconnectivity for me, right? And taking advantage of operating that as well, right? Those are the co-locations providing that disaster recovery, housing my business critical applications. And last but not least, the enterprise customers, right? The enterprise customers that are building these data centers within their corporate campus, maintaining that themselves, right? Building out their whole infrastructure. But these enterprise customers also leverage, based on the need, based on proximity, based on capacity needs, they'll also leverage co-location as well as cloud providers and hosting some of their applications that are accessible for their employees globally. Okay, so again, understand the who, but why do we need to understand the who is to understand their requirements, right? Each of those different data center providers or users or operators have different requirements that have density needs, capacity needs, power needs, types of interfaces that are required within the data center, i.e., storage array networks leveraging InfiniBand or fiber channels, et cetera, right? 100 gig, multiples of 100 gig or lower density. So understanding that their needs there within the interface, the types of data centers I alluded to earlier with some of these larger providers, you're talking about packing in more with less, or packing in tons of these 100 gig or 25 gig lanes into interconnectivity of different data centers within campuses, right? And so their requirements are at a higher scale, right? ROADM needs, right? What type of capabilities do I need from an amplification point of view? What type of distances do I need, right, pertaining to that? So there are all these different requirements that are necessary and are prioritized differently and different scaling for each of these different types of operators in the data center space. So if we go on to the next slide. Now it's looking a little bit more into the how, right? We talked, like I said, the applications, the who, and understanding their requirements, and understanding obviously the different types of data center interconnect options. Now, predominantly there are three, but maybe I would argue that there are four different options of interconnectivity, depending on obviously vantage points or how things are connected. The first one that I'll point out is leveraging coherent routing, right? Leveraging these optics or pluggables. We've been in the middle of a pluggable evolution over the last few years and looking at these coherent optics at a higher capacity rate, now going into smaller form factors, lower power, going into routing platforms, right? And handling, I'll say, smaller DCI distances, under 120 kilometers. Okay, so leveraging obviously now that demarcation that's now shifted from transceiver shelves, transponders, onto now routing platforms that meet their density and still meet that distance performance that they still require. Obviously looking at a total cost of ownership possibly if those requirements are still met. The other option, and looking at this more from a Ethernet plus storage array network, right? Or the diversity of client types of interfaces beyond just Ethernet interfaces. That's the second option, right? You're seeing obviously these large storage array networks being built out for that data storage and accessibility and higher performance of these storage networks and accessing that data. So you need solutions that can address that, and that's where optical transport solutions can have the diversity to address multiple client interfaces, such as fiber channels, right? Such as obviously those different 100 gig or 400 gig Ethernet services that are there as well. So combining that into a single transport shelf and having the versatility there. The third option, it's now packing in more with less. What do I mean by that? I've got a higher demand of these particular channels that I want to pack in more, right? So we're talking about 400 gig, 800 gig plus, right? over longer distances. So I want to pack in more with less fiber. So I want to maximize what I can put on that fiber. So it's this low order to high order aggregation and be able to pack in these particular channels. And you get into conversations of spectral efficiency. You get into conversations of line systems and being able to pack even more based on leveraging different bands. Looking at obviously C band, L band, and even other potential bands that are being discussed right now because of AI and the amount of channels that I need to maximize or aggregate on these fibers, right, for longer distances. The fourth option that I put on here, just as we look at this, right, data center campuses are nothing new, but what you're seeing is this growth of massive data center campuses and these large-scale data centers, buildings, in these particular campuses, in which you'll have interconnecting these buildings, these fiber cables that are providing thousands of pairs of fiber, right, interconnecting this. Now the distance is less, obviously, right? High demand of 400 gig, 400 gig between these buildings. You do have, obviously, when you're looking at storage, right, you do have fiber channel solutions that are there that you need to be able to support. So you need to be aware of these campuses that may necessarily not need the coherent optics, but now you're dealing with high density interconnectivity between buildings, as well as obviously leveraging your storage array network capabilities and those solutions that are relevant to those implementations. Okay, so again, four types of options, right, that you're looking at for interconnectivity between data center buildings and looking at this. The other thing I want to make sure we're always on the same page on, right? Everyone, we get into conversations at the lowest level when we're looking at data center connectivity, it's 2 points, understood. But at the end, not every operator obviously has just 2 data centers, right? There are multiple data centers. Data center connectivity is 2 or more, right? So as you look at not only even at a layer 1 and looking at high availability, right, and looking at different capabilities such as WSON, be able to diversify your infrastructure, but also high availability at your layer 2, layer 3 of interconnecting across all these different data centers, those end applications. So something to always keep in mind. Can't just always look at just a point-to-point service. Next slide. Okay, so as you can see, and understanding obviously the applications, right, and the demand, we haven't even hit all the demand on these applications, right? When you look at 5G infrastructures, as we've been going through over the last 5 years or so, right, you're looking at time synchronization. There's always these requirements that are important. But even with AI now, obviously with the proximity and need for AI inference and computing of all of these resources, your solution is going to be different, as I kind of alluded to in the previous slide, on not only the application, not only obviously the demand between points, buildings, data centers, of what you need from a density of how you're packing it in, how many channels are you supporting, right? You're going to, at the end of the day, what you're seeing is that it's not one solution to solve it all. So as I'm showing here, when you're looking at a DCI solution, we're talking about a solution that starts potentially at a router or not, right? Depending on those requirements or those bounds of the particular operator. You're looking at coherent optics that are relevant, that are providing that DCI demarcation to that routing infrastructure, hence coherent routing or IP over DWDM, leveraging line systems, even with coherent routing, to provide obviously the amplification of obviously these particular channels for further distances if needed, right? Or path fiber monitoring capabilities of these line systems. You're looking at transceiver shelves, right, which leverage the capability for lower to higher order support, right, for further distances, right, and density, right? So when you're looking at 400 gig or 100 gig density, these transceiver shelves focus on providing that over small 1, 2, 3, 4 RU type of shelves and giving you that density, but also packing in to a higher lane and providing that service, that transceiver service over higher distances. Okay. So, and then at the end, when you're looking at all of these platforms, right, everyone has a box that does X, Y, and Z, but at the end, you need to be able to instantiate, turn up, operate, maintain. You need tools, software tools, to make that easier for you and be able to model across these different layers if you are leveraging all of this, right? You need obviously the ability to turn up, configure this infrastructure potentially if you are taking it on your own to do that. And you need to be able to maintain and operate, right? As you change, add, identify a problem that's going on, looking at ways to optimize your interconnectivity, right? Being able to troubleshoot this, right? Having certain types of upgrade automation capabilities of maintaining and upgrading to later releases these applications. So software tooling becomes important across this. And if I go to the next slide, as we take a further look, it's now our portfolio of being able to address this, right? How is Ribbon doing this today? And as I alluded to, right, it's not a one solution solves all, right? This requires a comprehensive solution. You're going to have hybrid type of implementations from layer 1 to layer 3, and as well as require the tooling to maintain and instantiate, turn up all of these devices. So just a quick little review for everyone. I'll go through at least a bit of an introduction, some of the portfolio that's there that we can obviously talk deeper, introduce to different people later on if need be. But it's the comprehensiveness that we want to make sure we highlight to everybody here, right? Again, from IP and PLS portfolio, small to larger, depending on the density needs that are required or pay-grow needs that are there, right? From smaller type of devices to larger modular devices, and being able to provide that data center border router or interconnectivity between these data centers. There's our optical transport portfolio, right? And being able to provide disaggregated transceiver shells focused on providing that density that I talked about, right? In which when you look at some of the cards, I broke it up into two groups here, power cost optimized and capacity reach optimized. From a power cost optimized, we're talking about 400 gig to 800 gig transceiver density in a QCP-DD form factors, right? So being able to be 800 gig ready when and if you're going to need it. You're talking about a 2RU shelf that's providing the highest density today in the market. Being able to provide a fully loaded 2RU shelf of 25.6 terabit support, right? So this is a pretty dense solution that we're focusing on for some of these implementations on these particular implementations. The other part is capacity reach that I talked about. Packing more, right? Bigger pipe, but further, right? And the performance that have been happening, not only obviously in the form factor of these pluggables, the QCP-DD, and the capacities that are supported, but also now, with these DSPs, the capability of processing and improving your distance performance has greatly improved over time. We're now deploying in the field solutions that provide up to 1.2 terabit, and we're looking at further distances as we continue to evolve, further capacities as we further evolve. But you're looking at 1.2 type of capacities over 100 kilometers. So again, you're able to pack more into a single channel, right? And then leveraging even line systems to pack more of those channels onto a particular fiber. But what's even more important to me as I look at these is, again, these regional type of distances as well. As I said, going further, 800 gig, going over, type of regional distances of 1,200, 1,300 kilometers. And then 400 gig going coast to coast across countries, right, such as the US, 3,500 kilometers, being able to maintain that. And for further distances, of course, when you're looking at submarine capabilities, right? Then there's also the flexibility of our other portfolio, right? Not necessarily just a disaggregated optical transceiver shelf, but also a portfolio that gives you modular capability of providing that same technology that I went over of dense 100 gig, 400 gig, but more of that performance capability with the latest and greatest DSPs that are being deployed today in our portfolio today for customers, of not only providing that 800 gig of that type of distances that I was just talking about, but also having service flexibility, right? Service flexibility of providing fiber channel support, InfiniBand type of support as well, right? In these type of storage array networks, but also flexibility of your different types of rates coming in from a client standpoint, from Ethernet client standpoint, 10 gig, 2,500 gig. As I mentioned, these data centers, small to large, right? And the types of client interfaces that are coming in vary in all these different types of data centers. The other part to all of that too, when I say flexibility of these types of portfolios and these types of systems, is in that line system capability that's inherent in these systems as well. So amps, right? Being able to have pre and booster type of amplification available to you, or integrated in these cards as well. The ability of these multi-degree ROADMs, right, from smaller to larger, 4-degree, 9-degree, depending on how you're architecting or we help you architect these types of data center deployments, to larger degrees if necessary, right? As well as obviously these systems to monitor fiber paths, so channel monitoring capabilities, OTDR capabilities as well, that line systems and these cards can provide into these types of chassis. And last but not least, right, it's that smaller demarcation point that's necessary for some enterprise customers in these spoke deployments at their offices, right? You're looking at, smaller 1 gig, 10 gig type of NID solutions that we can offer. So it's comprehensiveness from a transport infrastructure as well as IP capability that's there to address these border router capabilities of interconnecting. And last but not least, our Muse application that provides the tooling, right? The tooling to instantiate, turn up, and maintain and operate. Right? If I go a little bit further into that, right, with regards to our Muse application, if we go to the next slide.
Oops, sorry about that.
No worries. So, as I've mentioned already, right, when you look at these implementations and hardware implementations that are there, and having the capability there, these operators are needing, again, tooling to maintain that, right? So it could be static on some of in these implementations, but at the end of the day, they still need to be able to maintain these applications and devices as well. So there's different values for different customers and different data center operators, as I mentioned before, of this type of software tooling. But this becomes the ecosystem of a comprehensive package, not only of obviously your transport technology, but being able to operate and maintain that infrastructure as well. And in our application with regards to Muse, now we're looking at tools to make it simpler to stand up these devices and functions, right? Being able to automate, obviously building out your services, building out your chassis itself for the function on that chassis and the service on those chassis. So automation toolkits to simplify that, template those particular types of services to make it easier for your operators to implement this and turn up particular boxes, as well as obviously maintaining it, right? So these automation toolkits are not just for instantiation, they're also for troubleshooting purposes, right? So our application with inherent workflow engine tools gives the operator the ability to not only instantiate, but have event-driven capabilities of identifying issues and then acting on that, right? So being able to being driven by a particular event, driving that automation change to address that, if possible, that particular issue that's going on. As we talked about, obviously, high availability and diversity, of course, across this different infrastructure. The other part is multi-vendor, right? At the end of the day, on these different implementations, I may have different vendor, devices that are there. So the ability to adapt not only southbound to these different devices, but also adapt northbound to IT systems that are leveraging is critical. So we're obviously very focused on being able to provide our customers the ability to obviously adapt to any of these devices and obviously northbound systems to simplify deliverance of obviously these functions. Then, of course, analytics, data monitoring, data mining capabilities that are there that we can use to troubleshoot and maintain these networks, right? There are applications that are available to the end user and operator, right, if they require that. And last but not least, it's the framework, right? At the end, as I said, I'll keep mentioning it, these data center implementations, yes, you can continue to focus on the massive scale data centers, but there are also the smaller scale data centers. Likewise with tooling, you may need only certain applications from a planning type of application that I highlight at the top, to obviously the controller capability, to obviously analytics type of apps. So we could focus on delivering this type of function within a microservice framework, right? And the adapters that are there. So you can scale in and out, in essence, of based on functions and size of a network. Okay, and with that, going on to the next slide. So just to kind of summarize a bit there, I've talked about obviously some of the drivers that are going on, obviously proximity being a big part of that, relevant to the application or the use case. We talked about obviously acceleration with AI. We talked about obviously the different data center operators that are there and their requirement needs and how they're implementing that, but as well as also the different options, right? And the flexibility of your portfolio to be able to address those different interconnect options across all of these uh, solutions or connectivity that's required. The last but not least here, it's looking at obviously a pivot point, right, of maintaining your own infrastructure yourself, or leveraging lit or leased services, right? So you can look at this in different ways, and being able to kind of justify it to yourself. When do I need to build it myself, right? What is that pivot point of the amount of services that dictate that I should probably look into maintaining this, operating it, building out this infrastructure myself? And you can break it out into four stages typically, right? I think one of those stages is relatively new. There's four stages, right? Obviously, there's providing those lit services, right? Maybe these are new territories or further out that obviously you don't have connectivity to today. So you're leveraging those tier 1 to tier 3 service providers to provide that 100 gig, 400 gig, whatever the rate service between those endpoints for you. There's different pros and cons to that. Obviously, they come at a cost, an OpEx model cost that you're having to address for continuation of a long period term. But as you're moving, right, and building that out, maybe there's another solution, right? One of the new solutions that are there is this managed optical fiber network, right, in which these service providers are providing the full infrastructure and operation, and be able to maintain this for the data center or the company or the enterprise company. Building out, maintaining, monitoring the services, obviously providing the full accessibility to what is needed, when needed, in expanding the services between these endpoints. So full management, operation, and interconnectivity between any of the endpoints. Then you're seeing obviously taking advantage of dark fiber, right? When you're looking to do this on your own at this point and putting the CapEx, you've got to also think about obviously OpEx as well into the mix, because now you're looking at maintaining this, so building up the resource, building up the expertise, but leveraging that fiber infrastructure and doing it on your own now and maintaining that. And last but not least, obviously proximity, and depending on what you've got in your network, fully operated and maintained by yourself, right? So those are the main different categories. But we've done some analysis on this. Obviously, we're happy to work with you and looking at each of these different stages, looking at the value and estimations that we've taken into account, right, in each of these. But you can quickly start to see that pivot point where it makes sense that you should be looking at maybe doing it myself or managing this managed optical fiber network or MOFN type of solution as well, or taking advantage of companies that are not only providing where the interconnectivity can be, but also providing that management resources as you're building it yourself as well, right? And not necessarily needing that resource expertise continuously, right? You can put this onto a particular vendor that can maintain this going forward. But you start to see this pivot of quantity of wavelength services, right? And you can see even with this 100 gig, and we could share some of the 400 gig analysis that we've done as well, you start to see this between 2 and 3, right, of wavelengths as you look at the totality over a period of time cumulatively, where it makes sense to start investing into building this, into leveraging dark fiber, and maintaining this as well yourself. Okay. With that, let me pass the baton back to Jonathan.
Thank you very much, Philippe. I see there's some questions. What I'll do is I'll spend really I think there's 3 more charts. I'll go through those and then we can go on to the discussion phase of this webinar. I thought I'd just bring to your attention, based on the type of framework that Philippe talked about, here's some use cases in terms of where we've helped various different types of customers for different types of DCI. So in the first one, this is with Telehouse. They're one of the larger data center operators in the world. In this particular case, when we mention these customers, by the way, it's based on announcements that we've made with the customers. You can go to our website and see those announcements. So with Telehouse, they are hosting a very large data center in central Paris. And what made this data center particularly unique was it had a huge amount of peering to various type of connectivity providers all around the world. So it was very attractive for companies to host their applications within the telehouse data center because they were in close proximity to all this peering. It shortened the latency, of course, in terms of communications. But because it was in central Paris, it was also very, very expensive. So what they did was they had a remote data center in the suburbs of Paris where the real estate was a lot cheaper. And we worked with them to build high-speed links between the downtown data center and the remote data center. And what they did was they offered virtual hosting for companies in the remote data center at a lot cheaper prices because of the real estate costs, but provided them effectively within milliseconds the same level of peering that they would get within the central Paris office. Another example, and this is going to the private type of optical network. This is working with an auto manufacturer. They had a network within about a 50 square mile, sort of a radius of data centers supporting various manufacturing activities and corporate activities, and they were looking to interconnect those. They had two types of traffic, both Ethernet traffic as well as fiber channel traffic that Philippe talked about before. And so because they had both these kinds of traffic, what they needed was an optical infrastructure. And they also wanted to have encryption, by the way, in terms of the fiber channel links. And because they're running this network themselves, they also needed to have fiber health management with OTDR, optical time domain reflectometry. So we worked with them to provide this particular infrastructure. You can see the network topology in the diagram at the right. So this was a pure private network run over dark fiber. Another company, VA Telecom, this is a service provider. Again, they're providing some connectivity between data centers and to enterprises that are using these data centers. This was just a recent announcement that we had. You can see this on the website as well. But what's nice about this is going up to 400G connectivity and supporting both fiber channel and Ethernet paths in terms of this data center connectivity. So they're using actually two different kinds of solutions for this. So what you see here is that there's various types of data center connectivity, and it's not the same sort of cut and paste for each one. There's always a little bit of tailoring that goes on. In terms of our solutions, if you're interested in exploring these further, we have some collateral. If you just type on the collateral part of the webinar screen, one type of solution we have is we call high density DCI. This is using a particular data center optimized platform, really meant for data center residency, very, very high capacity, very, very power efficient. This is where you have the greatest amounts of needs to connect data centers with each other. This supports two kinds of solutions, both ZR Plus solutions, where you can go from 400 ZR Plus to 800 ZR Plus without changing your blade. 800 ZR Plus, by the way, if someone says, well, it's not available yet, that's true, but we've built for that, and you can start today with 400 ZR Plus, and as these 800 ZR Plus pluggables start coming out in the middle of next year, you can double your capacity just by changing the pluggables. The other one is oriented towards enterprise DCI, and this is where you have much more of a need for both Ethernet and storage area networking connectivity, and in many cases just based on their sort of corporate mandates. Also a need to support layer 1 optical encryption, so we put it in brackets because it's optional. And you can actually, when you're running multiple services on the same wavelength, you can actually decide which services to encrypt and which services not to encrypt. So if you want to explore these solutions a bit more, just click on the collateral, download them. If you're interested, give us a call. So why ribbon? If you're sort of looking to consider a DCI solution, maybe you're familiar with us, maybe you're not. We are a global provider of communications solutions, and we make DCI easy. We have a complete solution set covering both the data layer, the MPLS layer, the DWDM layer, the optical, as well as the optical line systems when you need that, both covering amplification, of course, and the ROADMs. If you're looking for optical encryption, we have that as well, and we're keeping up with the latest trends. Besides using conventional sort of Whitfield Diffie key exchange, we also support two varieties of key exchange that are dealing with the post-quantum world. One is called PQC. That's post-quantum computing, where you have advanced algorithms that are much, much harder to, if you like, use quantum computing to actually decrypt. So it's using quantum computing to defeat quantum computing. The other one's a hardware solution called QKD, quantum key distribution, which is absolutely impossible, just from a physics point of view, to intercept the keys. As Philippe pointed out, we support multi-layer automation. So if you're looking at an IP and optical layer, we have a multi-layer view of both simultaneously. You don't need to have different management systems. And we have what's called do-it-yourself automation. You can take any set of manual keystrokes and turn them into an automated sequence. And we'll make it easy to integrate with your ecosystem, whether it's at the Muse controller layer or at the layer of the NEs themselves. They all support northbound APIs so that you can integrate them into your current management framework. We do boast superior technology. We have a unique solution, like I mentioned before, of upgradability on the same blade from 400 GZR plus to 800. We support wavelengths up to 1.2 T. And I can claim the highest density and lowest power in terms of these solutions. And if you work with us or you want to speak to people that have worked with us, you can see we're a preferred company to work with. We'll work with you to tailor configurations. We'll make installation easy. We'll provide the kind of field support at the levels that you need. So check us out and give us a call, and let's talk DCI. Thank you. I'll hand it back to you, Lance, as the host, I guess, to discuss any questions.
Yeah, thanks, Jonathan. Thanks, Philippe. We do have a few questions that came through, so we'll get to those. And just to remind everybody, following the webinar, you will be getting an email with a link to the replay and those two documents that that Jonathan is sharing right now. But on to the questions. So the first one that came through is, how can DCI be protected against fiber cuts?
I can do that. Philippe, you can do that. It's essentially, you can look at it at various kinds of layers, depending on the degree of connectivity. If your data centers are, if it's point to point, then what you're really looking at is just providing multiple optical links. Usually you have redundant links, and you can route those through different fibers. So you have automatic switchover from one fiber to another fiber. If you have a more complex arrangement, then you can actually do the recovery at the data level, where you're actually just doing alternate kinds of routing. So it's really just a matter of network engineering and nothing particularly sophisticated over there. It's sort of just the ABCs of how networks are built.
Yeah, that's right. That's right, Jonathan. Thank you. Sorry, I was on mute there. I had to take myself off. But you're right. At the end of the day, as you alluded to, it depends on the layer, right? And looking at high availability and the traffic engineering of that, right? If we're looking at layer 1, layer 2 infrastructure, or layer 1 especially, there's capabilities from a DWDM functionality in providing failover across different either ring topologies or mesh topologies, right? And how we're prioritizing that. From a layer 2 and up, right? There are traffic engineering capabilities of defining these risk groups, right? As well on the optical side as well, these shared risk groups, and looking at what the fibers are, and obviously identifying the right path to take, and all of a sudden any type of rerouting that needs to be done at a higher plane, right? And so it depends. It depends on, from an operator point of view and what their implementation is, what are the amount of diverse paths that they may have, right? Do they want to take advantage of high availability of these solutions at the lower layer, a combination with a higher layer, or higher layer only? But at the end, we'll work with you, right? We'll work with you, and we'll work with the architecture teams to identify what are the options there, right? And obviously, does that bring complexity or not, or do we want to push it into a different layer, right? If that simplifies operations of this and maintaining the traffic engineering. So again, it's many ways, I think, Jonathan, as you were pointing out, that you can slice and dice, obviously, protection paths in dealing with fiber cuts, right? But happy to work with you. And as I said before, I'll continue to say it, we support all of that portfolio and all of those technologies between layer 1 to layer 3. So very well aware of all the different options that we need to take, as well as the tooling to help with that. I hope that answered the question of whoever was asking.
Yeah, I think that was perfect. Thank you. Let's see. Next question, and I think we may have answered this in the presentation, but worth repeating. Will AI drive the need for edge data centers?
Yeah, let me take the first stab, and I think Jonathan obviously jump on in too as well. Jonathan hit that right in the beginning, right? And I was trying to allude through that when I was going over the applications that are driving edge data centers, right? We talked about AI training and AI inference, right? So right now, obviously the big push is these massive data centers dealing with the AI training aspect of it. So those are remote, those are centralized. But at the end of the day, right, as the user interface continues to improve, as the business case app continues to improve for those end users or end businesses, you need that actionable capability of AI, what they call the AI inference, closer to the end user, right? So closer, so leveraging these edge data centers that we're going to see a bigger land grab happening and implementations, whether it's a classic colo or a classic data center as a service type of provider, or even legacy service providers, the traditional, I hate to say the word legacy, but the traditional service provider, leveraging their central offices as these edge data centers, providing compute resources for AI applications as well. So absolutely. Jonathan, I'm sorry, anything else too?
No, not much to add other than sort of counterintuitively, like I said at the beginning, AI training could be done further away from the users. And in many cases, if you're a large operator and you're doing a lot of AI training, you might want to put your data center in some remote place where power is cheap, because the cost of power or the cost of doing that could well make up for any of the communications costs, which are probably cheaper than the power costs for having those data centers devoted to the training function themselves. I've seen some people actually talking about putting them up around the Arctic, just using natural cooling, but that's for another day.
That's a good point.
Yeah, that's an interesting idea for sure. In respect to time, I think we have enough time for one more. And so the last question I have for you two is, what if I want to build my own data center interconnect? How do I find the dark fiber?
Yeah, well, you can't do it without the dark fiber if you want to build your own. And that really depends on where you are in the world. In the USA, there's a lot of actually dark fiber providers, companies that are just devoted to that. And you can just Google them on the web and see the ones that are in your area. Other than that, you might be more dependent on service providers who own most of the fiber. In some cases, they're more than willing to lease you the dark fiber, particularly in sort of, well, this is the case certainly across North America. This is certainly a case across lots of Europe. In other parts of the world, you might find it more difficult to find dark fiber, and then you need to go to one of these sort of models whereby you're sort of leasing some of the connectivity from the service provider themselves. Or it could be a sort of a hybrid model where you have some routes satisfied by dark fiber and other parts of the routes are satisfied through these services, if you're building your own data center kind of framework. That's just the reality of the particular markets.
Yeah. And just to add, there are, just like the information we were showing earlier in the presentation of websites that offer, all the data centers that are coming in that are available in particular markets. There are website applications that also identify in particular markets on regions of availability of dark fiber. There are also partners, right, that may be different in different countries and regions, as Jonathan mentioned, and who has that. But you're looking at least from a U.S. point of view, there are a number of utility companies, critical infrastructure companies that built out these fiber infrastructures in the past, right? And they overbuilt, of course, the infrastructure. You're putting the fiber down, might as well put as much as possible. So there are many of these types of utility companies that are there. There are these applications that are there that give you websites that give you all this information of who it might be. And then there's partners. There's partners that we leverage as well. Not only obviously from a partner of resale and in staging deployment, but also finding these types of resources that are available or providers of the dark fiber that could be used.
All right. Well, thank you guys. Thank you. I think that's all the questions we have today for this webinar. Just to close out, I want to thank everybody for attending number one. I know it's a busy time of year, so thanks for joining us today. As I mentioned at the top, we will have an email later on this afternoon with a link to the replay. It'll have these two documents that you can download. Obviously, you can respond to that email with any questions you may have. There's plenty of other ways to find us at ribbоncommunications.com. Feel free to reach out to Philippe and Jonathan if you have questions as well. We can definitely get you in touch with these guys to check off any loose ends you may have. But again, I just wanted to thank you all for your time, and I'll throw it back to, I guess, Jonathan and Philippe for any parting words.
No, thank you very much.
Thank you. I mean, it's an exciting time. It's been exciting, obviously, for a decade already looking at the evolution, but it is accelerating as we've gone through at a high rate and evolving further and further as we continue to look at this at a high rate as well. Over the last few months, just looking at the density needs that are happening, the power dependencies, right? So exciting time, Jonathan. I think it's when you're looking at 2025, it's like, where do we go, right? I mean, a lot of growth happening in the market.
No doubt about that. All right, thanks again, you two. Thanks again, everyone. Happy holidays, and we will see you on the next webinar. Take care.
Thank you.
Thank you.